Welcome back, everyone. My name is Adam Soroka. I'm the Managing Director for Cavendish Group International. We've had a storming morning so far in Future Downstream. I hope you've enjoyed it as much as I have. We are now on to the afternoon session, which we're very excited about. One thing which is brilliant to see is lots of questions coming in onto the panels. Equally, if there are any presentations that are taking place, please feel free to make an entry in the chat box. Put whatever you feel is necessary. We do want it as part of the wider discussion, even for later on. So please do use that, and please also see the wonderful companies we have on the exhibition or the virtual exhibition floor. So we now have our technology partner Flutura. We've got a wonderful presentation coming up on AI application. It's actually called Refineries of the Future, Unlocking Previously Hidden or Lost Profits. And it's presented by the very excellent Christian Retek, Chief Revenue Officer for Flutura. So over to you, Christian.
Good morning, afternoon, or evening to the attendees at Future Downstream. And if you're watching this at a later time, thank you for joining us today. I'm a technology enthusiast with a formal education in computing and computer electronics who has spent the last decade working for innovative software solution providers that offer digital twins in robotics, education, and the defense industry. In another life, I developed software for Google and was on the original team that incubated and developed a device many of you greet with, "Hello, Google." I'm currently the acting Chief Revenue Officer at Flutura Decision Sciences and Analytics. I'm also the child of an immigrant family that escaped to North America when war broke out in former Yugoslavia at the start of the 90s. Growing up was a challenge because my father worked for the reliability and maintenance department on a continental shift. I never really saw the man as much as I would have liked to because he was busy paying for my education, either putting out a fire or sleeping from the previous night's shift. Now, Flutura is currently helping refineries and chemical manufacturers maximize their margins while simultaneously reducing their carbon intensities. And we're doing this by predicting equipment failures, process upsets, and swings in quality. By integrating all the available data across real-time sensors, integrating engineering first principles models, and artificial intelligence models, we serve the top 100 across energy and biomanufacturing to provide near real-time insight into the health of the entire fleet of assets, with a warning at the earliest onset of performance deviations across static, rotating, heat transfer equipment, things like turbines, compressors, pumps, heat exchangers, distillation columns, reactors, pressure vessels, separators, blowers, you name it. We'll identify the true operating limits within safe operating windows to maximize asset performance and availability. And lastly, we allow operators to run what-if scenarios using first principle models like HYSYS, PetroSim, Pro2, and reactor models without requiring engineering resources and assistance. Now, what this does is it enables plant-level operations to safely maximize their performance and the control they have over production without creating any kind of negative impact. Let's begin by casting our minds 10 to 20 years in the future and asking ourselves what it would take to create a future that we're happy about, that we're truly actually excited about. Personally, I want to think about the future and not think that it sucks. And there's a lot of discussions lately, especially thanks to the ease of communications over the internet, that has made folks pessimistic to the way the future could end up presenting itself. Now, based on this graph here, it appears there's a lot of problem solving that needs to be done to transform that future into something that doesn't suck. And one of these problems is the great resignation and the talent crunch we're experiencing. The best and brightest within our industry are aging out of the workforce. Their tribal knowledge is leaving with them. The folks that can diagnose equipment issues simply by smelling it, they're being replaced by a new guard. That information that's leaving needs to be captured somehow if we're to solve the problems of old and move towards solving newer ones. Now, it's worth noting that life cannot simply be about solving one miserable problem after another. The shining light on another problem, many scientists, academics, and politicians have labeled the year 2050 as a sort of doomsday deadline for our planet to reduce greenhouse gas emissions or offset those emissions in order to avoid a climate catastrophe. Now, I'm not a doomsayer, despite what this slide may have you believe. I believe that as long as we continue the path we're on, we're not complacent, and have a continued high sense of urgency in transforming the way we're utilizing hydrocarbons, it would seem like they have a strong future in this net zero world and right on time. Now, we're going to need a lot more energy now that the second and third world countries are digitizing. Countries like Africa are having their populations get access to banking and loans thanks to cryptocurrencies, and they need power. Billions who could not access debt to break out of poverty are now going to be adding additional burdens to the world energy production. So let's take a moment and talk about who we served. Now, throughout the last decade, we've had a variety of organizations come to us experiencing process level challenges, seeking to use artificial intelligence to improve their operations and drive towards their definition of the operation of the future. Our clients have spanned across a variety of industries and included discrete and batch manufacturing, but they've all had an underlying entry point, and it's usually predictive. And I'll expand on that shortly. For the sake of this discussion, we're going to focus on the work we've done supporting the refining and chemical industries because this is Future Downstream. Welcome. So our first stop begins all the way downstream with a chemical manufacturing plant. Now, this company had approached us asking for help to find a way to measure their intermediate outputs at each stage of their batch manufacturing process, which they weren't doing at the time. They were measuring only at the end of the process, not partway through with different sequences. Moreover, they didn't have much in the way of visualizing the plant back then. Now, once we'd implemented the basic monitoring capabilities at an equipment level, this unlocked the ability for the solution to inform them in near real time of potential process bottlenecks. While implementing Cerebra, this manufacturer started with modeling a single line for a handful of products. The production trial we engaged in allowed them to baseline their intermediate outputs against their golden batch before completing this multi-stage process. That way, they were able to adjust at each intermediate stage of the process, as opposed to only adjusting at the very end to achieve consistency in the amount of golden batches in production, in addition to the production improvements, which were secondary. This production trial was scaled within 2 years to include nearly 8,000 products across 150 lines, enabling them to unlock an additional 60 million in annualized business impact. Now, reflecting on the case study we just outlined, most, if not all, industrial operations are at varying stages of what we're calling the digital maturity spectrum. I'd like to use Tesla as an example here because it's simple, it's elegant, and it's timely. Contextually speaking, the internal combustion engine would be your legacy technology here on the left-hand side, and the full self-driving Tesla would be your operation of the future. Over the next 5 to 10 years, I predict we're going to see over 80% of the refineries transform, leveraging these digital assistants that tirelessly look for equipment failures and process upsets, even if there are no people present. The remaining 20% will go the way of the refineries of the past, unless we find a way to help them be competitive, given the constraints that are currently being placed on them. Now, entry into the digital maturity spectrum begins with a concept that you may or may not have heard called APM 4.0. The acronym stands for Asset Performance Management 4.0, and it's the newest evolution of the buzzword, like digital twin, like digital transformation. Now, I'm not typically a fan of buzzwords, but they are necessary for an intelligent dialogue. So as far as Asset Performance 4.0, what it is essentially we've got instrumentation and sensors sending 24/7 data constantly to a centralized place. Now that cycle is running, continually sending signals, vibration analysis, all the way down to more complex things like CCTV and vision, just cycling on through, giving us that data. Now, many of these organizations who are earlier on the digital maturity spectrum that I've mentioned don't have that data immediately available, so they have to get the sensors and instrumentation in place. For those that do, they're able to take that massive dump of data coming into their cloud, on-prem, the edge, doesn't matter where it's going, we'll work with it. They layer the first principles models on top of that, and that's where you get your predictive analytics. Now, your first principle models are your equipment specs, which could be sitting in a cabinet in the back office of the refinery. They could be sitting with the equipment manufacturer. They could be packaged away somewhere nearby for the folks to have access to. Those equipment specifications are considered your first principles models, along with your HYSYS, your Petrosin, your Pro2, and all those other tools. And then I'd mentioned earlier, due to the grand resignation, getting that embedded in tribal knowledge inside the first principles models is incredibly important, because then you can scale it regardless of whether those folks are there or not. Now, with just pervasive technology and first principles models, a very talented individual could produce a predictive analytics piece. But it would take an incredibly long time, which is where we come in. We've layered on top of that the artificial intelligence models, and we'll apply it as much as necessary. So in some cases, something as simple as Bernoulli's equation is sufficient for modeling a piece of equipment or process. In other cases, we need full neural nets, we need deep learning, heuristics, everything to be able to make this function properly. So Asset Performance Management 4.0 is the equipment level entry point, maximizing equipment. Once you have the equipment level, you can go process, you can go system. Equipment, process, system. So for those of you that are viewing this with a keen interest in making sure your operation hits the ground running and see success with their journey through the digital maturity spectrum, we have one piece of advice. And this might upset folks, but you don't want this project led by IT. After a decade of implementing artificial intelligence solutions, we've seen some alarming trends we'd like to share with you that we believe explain why most organizations don't see ROI as quickly as they'd like to. It's because they focus on developing a cool solution first, or they see something and goes, "This is a really cool solution." They'll hand it over to IT because they're the stakeholder who has to make sure it meets cybersecurity requirements, and then it'll get kicked back to a data science problem, and then it'll get kicked back into a business problem and will finally involve the operational folks. Giving new technology to operational folks like my father, it's been like pulling teeth. Man hasn't picked up a cell phone until last year. They've been out for a little while. Now he's an executive who sits on his phone all the time, but he used to be an MRO guy. Aim instead for this. Talk about a business problem first and foremost. If it does not get ignited, triggered at a business problem level with the operational folks, and this is counterintuitive because they are often the laggards to technology acceptance, get the business problem first. Then layer the data science on top of it. Like I'd mentioned, in some cases, a simple equation will work. In other cases, you need a full-blown model. And then you have a right solution that you can then take with your little group, build consensus on that solution. You've optimized a piece of equipment. You've shown some value. Makes it very easy for you to go back to leadership and ask for more budget to expand the work artificial intelligence is doing and get yourself more digital assistance. Now, this is another case. This is the world's largest oil and gas separation facility. They started off with 10 different compressor models with us. And within 10 weeks, we built a standardized model across all those different compressors. And that's now deployed over 100 different compressors. And if you can imagine, you take an organization like this, who's known for having the largest fleet of compressors, as well as the world's lowest carbon intensity production in their products. For them, seeing additional carbon intensity reductions is right up their alley and right up their message and values that they're presenting, especially at a time like today when sustainability is so important. But on top of that, those increases in efficiency, hell, a 4% increase in asset lifetime across a giant fleet. We haven't even discussed the capital expenditure improvements that are going to happen because they get 4% more out of everything. That's an additional value that's not listed here. These folks now have anywhere from 6 weeks to 2 days of a heads up that a compressor may potentially fail. So they don't even have to flare the line anymore because they know when there's going to be unplanned downtime. For this particular solution, is deployed over several hundred compressors. They're seeing about a 98% accuracy. Now, I mentioned earlier this idea of APM 4.0 and the theme of equipment, process, system. Equipment, process, system. Let me elaborate on what I mean by that and how it pertains to the folks watching this and our humble professional recommendations on how you can avoid having AI implementations take 1.5 to 2 years to actually see an actionable ROI. You start at the equipment level, getting equipment level data. And this is why we go to the operational folks to identify their problem first. Because if they have a list of bad actors within the refinery, and I trust that there are people who are working on those bad actors, they're going to have recurring bad actors that they're going to need fixed. Well, let's put a digital assistant on top of that so not everybody has to be reacting to the problem all the time. We start with the health diagnostics. Once we've got enough data, I can tell you how it's performing and give you a diagnostic dashboard. Then I can do things like predictive maintenance of critical equipment to make sure that we're limiting your unplanned downtime and making use of your planned downtime. And equipment performance degradation diagnostics. So as soon as there's a degradation in the equipment, as long as it's not a false negative or a false positive, I want somebody alerted and aware of that. And I may even want to trigger a work order to go look at this piece of information automatically. You can do that through sophisticated systems like this. And once you've got enough sensors and instrumentation at the equipment level, we can now expand to the process level and start dealing with real problems. So let's talk about procedural automation for a second here. Let's say naphtha prices increase and you want to go to a higher production rate. If you had the HYSYS model integrated, you could check and say, if I want to achieve higher production, do I have the capacity to achieve it? You can answer that question at the operator level using Cerebra, not the engineer level, because the tools are integrated and visualized in such a way that an operator who doesn't have the expertise of an engineer or the capabilities gets access to that information to make the right decisions. The operator now has the means to run a HYSYS, PetroSim, or a Pro2 model or a reactor model and check if it's feasible, as well as how much room he has within his control to achieve those outcomes without causing degradation or failures to the equipment. Let's say we have a serious process upset and it leads to legal ramifications, and we're being challenged. Well, because you have the heartbeat at the machine level, second by second, data by data, you can measure the physics of what happened. If I have a process upset, I can diagnose it back to tell you exactly what was responsible for the process upset and what we can do in the future to avoid it. And then we can move towards some crazy level problems, which are things like emissions monitoring and control, your carbon accounting at the machine level. So instead of the director of sustainability getting reports from other team members, he's just looking at a dashboard that says this is what our current outputs are in near real time if we choose to host it on the edge, or with a slight delay if we choose to host it on the cloud. Just need to determine where we need the calculation to happen. And the gold standard is that world where you've got the PIMS integration and you have the economics and planning completely integrated, because the economics and planning personnel are the folks who can identify where there are opportunities to optimize the refinery's function, where they're hitting constraints in production, and where there are potential problems that can be fixed quickly. So these are the people that hold the keys to the actual refinery's optimization opportunities. And if we give them access to a PIMS integration, they can now connect that all the way back to the equipment level and let you know exactly what's going on and maximize the production within the refinery. Now, I talked about collaboration earlier and how important it is. Here at Flutura, there are the 5 key performance indicators we are trying to enable. We are on Gartner's Magic Quadrant, by the way. We have very, very high customer reviews on there. And we've broken our decision-making space, as we call it, within the solution into a couple of different key areas. So the supply chain and the strategic planning team are going to have things they care about. I just mentioned it with procedural automation and the naphtha prices and the cooling situation. But I also look at ESG and sustainability. So that's your carbon intensity assessment, your carbon accounting, quality assurance, which we talked about with the first case study in the chemical production facility, production assurance, which is the diagnostics of production upsets, being able to maximize use of our planning and doing RCA. And then from the safety, reliability, and PSM side, that's the turnaround and discovery planning, things like spare part inventories, and then the equipment health and predictive analytics components. So all team members within the refinery are encapsulated within this particular collaborative decisions-making space, and we ask our clients where they want to begin, what problem they want to solve first. So how does the actual data flow following the data and answering the question about how we turn data into gold? Once Cerebra has consolidated and modeled your plant level data, we compare the actual output of equipment with the expected outputs per the model to determine where there are performance deviations. Now, this will tell us where equipment performance is degrading, why it's degrading, and will even suggest corrective action before there's further process upsets or failures. Now, this improves the efficiency of the plant by increasing downtime significantly. Coming back to my dad, if he had this, he wouldn't be running to the plant constantly when there's a problem, but instead he'd start investing his time into fixing things before they broke down, so he could spend more time with his family. No one should have to wake up at 2 a.m. in the morning to run to work, stressed out, cortisol raging, not knowing when they're getting back to their bed. Now, we model the process using HYSYS, Pro2, PetroSim, PipeSim, whatever our customers ask for, and see that we're not getting the expected performance from a particular process area or the equipment's not showing the process as modeled. We'll help you adjust those equipment operating parameters in order to achieve the performance anticipated by the models. Now, one final point here. It'll also help maximize production of your higher value products. So for example, when naphtha makes more margin than diesel, you know you're going to need extra cooling. By ensuring cooling is provided at the right area of the process, you can push to make more naphtha if the plant has the capacity to do so. In this case, a digital assistant would be deployed to help achieve this outcome. Now, in all circumstances, whether you're looking at pump cavitation warnings, aka pump health as we call that digital assistant, heat exchanger failure modes like fouling, which is another digital assistant for us, compressor health, another digital assistant for us. You need the data, you need the models, and you need some visualizations to do something, because people operationally respect what you inspect. Dashboards are a godsend when it comes to change management. I want to leave off with our Refinery of the Future case study. This is a refinery in Big Springs, about 75,000 barrels at this plant, 10,000 different sensor points, a significant amount of heat transfer and rotating equipment and some static equipment included in this case study. And we started off our production trial taking a look at the front end of the refinery, and we scaled it across some more equipment. And within 6 months of us working together, we've got signal by signal heartbeats of what's going on at the refinery, so we can calculate these things and work with their engineering teams. We saw a relative 12% reduction in fuel gas for their furnaces by improving heat exchanger performance. So we showed them that heat exchangers were degrading. They took 3 of those heat exchangers down due to fouling, they cleaned them, and now they're seeing performance levels they haven't seen since 2014. They saw a 1% increase in throughput, which we didn't intend to happen. And they also saw a 15% reduction in energy consumption and an improvement in the mean time between failures. Now, if you ask their folks, they'll say it's closer to a 20% improvement in mean time between failures, but I like to keep all of our numbers conservative. Now, that production trial alone that started off at a chunk of the refinery was able to see over $3.1 million in value. And now that we're scaling across all of their refineries, responsible for 302,000 barrels of oil per day, there's a pretty significant carbon intensity reduction as well across their value chain, courtesy of the reductions in fuel gas and things going down. So why us versus the other folks, and why is this a conversation worth having? If you look at the traditional technology stack, and by traditional, these aren't new technologies, but it's worth noting that there are some patterns emerging. You're going to need an OT ecosystem no matter who you go with. You're going to need a cloud infrastructure, whether it's Microsoft, it's Amazon, it's on premises, or it's some kind of hybrid. We will plug into that. And now this is where the road hits the rubber, or the rubber hits the road, I should say. You've also got in your traditional tech stack 10 different systems that ultimately create this bespoke pointed solution for you. Whether it's your ERP, your laboratory information management systems, an individual asset performance management system, and your simulation tools, which we talked about. You got to invest a different amount into each of those technologies. Now, on top of that, you've got to create a data contextualizing platform so you can get a common data layer, and then you can do reporting. You can start to work on creating your own coded environments, models, etc. And you arrive at a bespoke solution. There's several $1 million of investment on the left side here. And what's interesting about it is that it's a very high total cost of ownership, low ROI way of looking at the solution, and it's very data integration centric. If you look at this, I've got all these pieces of software that require connections and time to set up those connections and configure them, and training so that folks will use them. No wonder change management has been hard. No wonder these projects are taking 1.5 to 2 years. Why don't we take the alternate approach this time? Focus instead on something that's scalability centric. So take some asset that you're using, or a handful of assets that you're using within your refineries, and use those as the things on which you'll perform a production trial. Focus on generating an ROI, and focus on scaling that ROI across the organization as quickly and effectively as possible. In this case, one throat to choke. You have a problem, you need support, you need some kind of configuration, you want to scale the AI to the next digital assistant, you have one person to call. You want to solve the problem, you have one person to call. You want to create a digital assistant that lets you know when you're getting close to flooding a tower, let the digital assistant do it. You don't need all this extra stuff here on the left-hand side. And we're trying to find a better way for these folks to deploy solutions that are agnostic. So if the company that we're working with, one of our customers, decides to buy an asset that's out of their normal operating procedures, it's very easy for them to extend the solution, Cerebra, and deploy it at this new facility with new data sets, because we don't care where the data comes from. We don't care what piece of equipment it is. We are not proprietary whatsoever. We are an open garden for you to come into and plant whatever you'd like. Trust isn't what we do, it's the results of what we do. And we've got a very bright future ahead of us. Thank you for joining me today.
Oh, I love that ending, Christian. I love the last line you used in there. That's really good about trust. I love that. That really resonates with me. Very good. Excellent presentation. Very sad to when you're talking about what your father did, but actually it was really well connected with the presentation because you're absolutely right. You know, you talk about shutdowns, turnarounds, maintenance in refineries, and how it takes people away from their general day-to-day life. It's very, very difficult. I know a number of refinery managers, and it's a very, very tough job. So anything that can facilitate, prediction, as you mentioned, is going to help that. I think it's going to help all sort of parts of life. So fantastic, Christian. Thanks a lot for that. Flutura have a wonderful exhibition booth, virtual booth. Please go and see them, and also contact Christian for any further information on his presentation. Now we move on to a wonderful panel. It's titled "Defining the Digital Journey: Creating a Data Connected Facility." And it's moderated by the absolutely fantastic Udayan Vyas, who's emerging technology strategist for Chevron. So over to you, Vine.